All right, so the second speaker is Guanqi Zhu. Guanqi is a Ph.D. candidate and active architect. His research field includes digital design, interactive installations, material computation, artificial intelligence, and robotic construction. Now we welcome Guanqi to present his presentation.
Yeah, I will start to share my screen. So, yeah. The topic I'm going to share today is about the round earth constructions and how it can be empowered by the robotic fabrication and robotic arms. So the final picture is just one of the outcomes in this experiment. And it fully displays that the authentic variation on the vertical facade of the round earth. So just in contrast, we can have a look at those traditional round earth or earth buildings in the histories, which is totally finished by one homogeneous material, right? So it also has a really long histories. So take the Great Wall as an example. The first part of the Great Wall started to be built in the Qin dynasties, and it also appears in a lot of places, in a lot of areas in the world, such as in India or Africa. So although nowadays that it seems that the concrete is the most popular building material, so there are still some architects are pursuing for those traditional fabrication techniques. So it is because it has a lot of good advantages, such as it may provide some stunning aesthetic facade appearance, and at the same time, it has a lot of good structural performance. So this group of the pictures illustrates that how the traditional fabrication, how the traditional round earth wall can be fabricated. So for the first image, we can see the workers need to build a large metal formwork. So it is totally the same as the concrete constructions. And the second one is the workers just need to pour the earth material in this mold, right? And you can see they are standing on mold and using that pneumatic hammers to compress the earth together. So it only takes 7 days, around 7 days, rather than 3 weeks or 4 weeks in the concrete constructions. You can just remove the molds, and this is the final outcomes. It's a round earth wall. So for the material parts, I cooperated with Professor Mu Jun, who is a professor in Beijing Architectural Universities, and this diagram shows that he lists his students. They already finished a lot of research pavilions or some real round construction walls in different areas in China. So one of their research directions is how they can improve this traditional fabrication technique in the current key buildings, such as the museum. You can see it from these pictures that some of the main structures are totally finished by the round earth, and some height can reach more than 10 meters or 15 meters. So one of another their research is about their structural performance. So this is just a group of the pictures about the earth samples from different areas. But actually, as an architect, as a designers, what attracted me most is the colors. So that's why I have this experiment. So this is another really good precedence which illustrate why I need to do this experiment. It's a tourist center building in Dongying City. So it is a really good contrast. We can have a look at the outer surface, the outer wall and the interior wall. So the outer wall is totally finished by one homogeneous materials, one same materials. But for the interior wall, it's really different. So the architects just abstract the concept from the traditional Chinese landscape painting and reflect it on this round earth wall constructions. But at this process, they met a lot of problems. If you still have some memory about these pictures, the whole fabrication process is just like walking in a black box. It is really hard for the workers to distribute the material in this black box. it is hard for them to calculate which parts needs more materials, which parts need less materials. And it is also hard for the workers to blend the materials with the correct colors. It is also hard for them to make sure that the final outcome is as same as the design, right? So here are my all the research questions. Is there any method to improve the aesthetic performance? Yes, we can fully utilize the vertical directions. We can try to add some patterns on the facade. So why to use the robotic arms and robotic fabrications? Because we always can see there's a lot of good advantages for the robotic arms. It's smart, the whole process is fully automatic, and it will never make some mistakes, just like the human beings. And how this can improve the construction efficiency. We can utilize the robot to do the material distributions, because the robot will not make mistake as soon as your program is correct. So here are my all the research methodologies. So for the first parts, I just designed anti-effectors, which is tools for the robotic arms. So for these anti-effectors, it consists of two main parts. The first one is the material extrusion and the material blender parts. So after we finished these hardware designs and fabrications, we need to establish signal cables between our anti-effectors to our control box. So forgive that part, that belongs to another project. So this is the whole working environment. This is the workflow. For the first part, is a design scheme. So at here, I basically used the Rhino-Cross and Grasshopper platforms. So if you input any image in the Grasshoppers, the program will automatically transcode your image into two main parts of the important data: the spatial points and the color information of the pixels, right? So the spatial points will be used to guide to locate the robotic arms, and the color information, which is the RGB, will continue to be breakdowns for the motors, for the blenders of on the anti-effectors. So on the final step, it's a continuous process, and as a human being, you just need to stand there and wait. The robotic will extrude the right material at the right point. Yeah, that's it. So before the automatic fabrications, we still need to do some manual testing, right? Because we need to build some knowledge for the robots. So this is the first manual prototype of the color blending. So you can see the left one is the 100% of the yellow earth material. The red one, the right one is totally 100% of the red materials. And the middle one, you can see I tried different blending recipe, different ratios. You can see the color is changing, right? So again, before we are doing some robotic fabrications, we need to prepare all the tools for the human beings. So those are all the tools what we need in this experiment: the mixing tank, the mold, the hammers, the raw materials, and some additive agents. So as you can see, how those traditional fabrication material or tools can be transformed in an automatic ways for the robotic arms. So you still can see the mixing tanks is here, the material extrusions is here, the extrusion nozzles is here. This is the mold, right? So this diagrams illustrates that how an image will be transcode into the how to extract the informations from pictures. And the most important part is the ratio between two different materials. It is because you can see I only have two tanks at here, but at some point you can just remove one of the tank and replace it with new colors. So if you have some experience about the robotic fabrications, the path planning for this experiment is quite easy and straightforward. So all the points will be moved point by point, layer by layer, just like the normal 3D printing ways. So we also designed a lot of different size of the molds for different material properties. And this is the first prototype about this experiment. As you can see, this is the first point, this is the second point, the final point. So we can clearly see that the color gradient from the first point to the last point. We can see the mixing tank, we can see the anti-factor works successfully. So this is much more clear. So if we have only 9 dots at here, so this is the totally 100% of the yellow color. This is the totally red color. It's a time lapse about the whole experiment process. I'm quite sorry that I met a lot of lockdown at that time when I was in Beijing, so I do not have too much high quality media or pictures to illustrate the whole process. So maybe you can find that at different points, the rotation speed and the rotation time is different. So after the blended at each one point, the color will be unique and different. So after we distribute the material in the mold, we still need some green buildings using some green material. But the different things is friends, if you are interested about that.
To ask Guanqi Zhu. Could you please share your screen? Maybe page 25. Thank you.
Thank you, Albert. Okay.
Page 25, maybe. So in your robotic system, only two colors of Earth can you use. So how can you implement the green color in your page 27?
Yeah, it's right. The material tank here is flexible. You can replace it at any times. It is because the area limitations. So after I printed the first layers, I can replace it with another kind of the new colors so that I can achieve this. Yeah, it's not fixed.
Okay. Yeah. So another question is, can you how many color? How many colors can you use?
Yeah, actually,
yeah. Or depend on the Earth.
So as you can see, the raw materials, the raw earth material, the natural color is only two, which is the totally red and the totally yellow, and the orange is a kind of the color between these two. And for the green ones, I just added some color toner, just add some colors on the raw materials. That's all. It's totally depends on the colors, what kind of the colors you edited. So in that project, they are using a lot of different colors, or maybe they also tried some natural materials such as the coffee, some coffee materials or different things. You may, if you're interested with the color, you may try to search about this project. But there's a lot of possibilities.
Okay, thank you. And
so for the coloring gradient here, the strength, right? You are talking about those here. One for you. Really fast. So in this paper, I'm trying to discuss about compression ratio, if my memory is correct. you can see here. So after you print it ultimate mode, right? So you still need some high strength to compress them together. It is recommended that the compression ratio is 3:1, but you can read it here. If you only finished by manual, the compression ratio is only 2:1. Maybe my strength is not enough, but if you are using some mechanical method to compress it really dense, it will absolutely improve the structural performance. Yeah.
I have one question for
thank you
for
for
Guanqi.
Mm-hmm.
For your method, I'm wondering have you ever considered using some intermediate materials such as resin to strengthen the structural performance or the building process?
Do you mean to add some different agents to improve the? I never tried about the resin. It is because I have another project about the resin. I'm going to share the screens and I will try to find that. I have another one about the resin. Maybe you can see the resin will be used in this one. This one will be the resin is quite important. So the material for this one is fiber reinforcement polymer, which is short for FRP. So if you are interested with that, I don't have a VPN. So for this material, it's highly relying on the resin, but I don't think that's a quite good idea to add some liquids in the round earth constructions, although we can try to add different things together. At here, I just tried 4 types of the additive agents, and I guess that the resin is a little bit similar with the rice water. Whatever is just something which may make it much more stronger. But I think there's numerous agent things we can try to add it. We can have a try. Yeah.
Thank you.